The story of America's most violent plant began not with a scientist in a laboratory, but with a settler's cow collapsing in a marsh. In the damp wetlands of the 18th century, European colonists watched their livestock stumble, then seize with terrifying convulsions. The animals' muscles locked, their legs thrashed against the mud, and they died within minutes, foaming at the mouth beside the very greenery they had just eaten. Curious and alarmed, a colonial botanist waded into that same mire. He knelt, pulling at a lush plant with feathery leaves. He unearthed its thick white root, which released a sweet, earthy scent, reminiscent of parsnip. But when he sliced it open, he found not solid flesh, but a series of hollow, crosswise chambers, oozing a strange, yellowish resin, a fatal signature hidden beneath a familiar smell. Word of the marsh killer spread through farming communities. They learned to spot its clusters of small white flowers atop stems often streaked with purple. Yet the true danger remained buried. That innocent-looking root, if even a walnut-sized piece was eaten, could trigger a neurological storm. The plant offered no second chances, its violence waiting just below the soil of the New World. As the 19th century dawned, the mysterious plant that had killed livestock for decades finally received a formal name. Botanist John Torrey, working with pressed specimens and field notes, carefully examined its features. He noted the hollow stems, often streaked with distinctive purple blotches, and the umbrella-like clusters of tiny white flowers that bloomed in summer wetlands. This was no longer just a farmer's observation, it was becoming science. Torrey's crucial work involved comparison. He laid the water hemlock specimen beside its harmless look-alike, the wild carrot. The differences became stark under scrutiny. While both had lacy leaves, the hemlock's stems were smooth and hairless, marked with those telltale purple streaks. Its root, when sliced, revealed not a solid core, but a series of transverse chambers, often filled with a yellowish, oily sap. This was the key identifier. With this detailed morphology, Torrey classified the plant as Cicuta maculata, formally entering it into the botanical record. The name gave the killer an identity, but the reason for its violence remained locked inside that chambered root. Foragers and farmers now had a description to memorize, a way to distinguish a deadly imposter from a safe meal growing in the same damp soil. The botanist's careful classification in the previous decades meant little to the farmer who found his cow staggering in the pasture one summer afternoon in the 1850s. The animal had been grazing near a creek bed where its muzzle had likely brushed against the exposed tuberous root of a water hemlock plant. Within minutes, the peaceful scene shattered as the cow's legs began to jerk uncontrollably. The farmer watched, horrified, as the convulsions intensified into violent, thrashing seizures. The beast's muscles locked and spasmed, its body slamming against the earth. Foam, thick and white, bubbled from its mouth and nostrils, a classic sign of profound neurological distress. The attack was relentless. The cow never regained its feet, its life extinguished in a matter of frantic, terrifying minutes. When the terrible stillness finally settled over the pasture, the farmer acted. He knew this was no ordinary death. With a cautious hand, he cut a piece of the strange, pale root from the wet soil where his cow had fallen. He wrapped it in cloth, determined to take this evidence to the local doctor. He needed to know what kind of plant could kill with such brutal, shocking speed. That preserved root fragment from the farmer's field eventually made its way to a university laboratory in the late 1800s. There, a chemist carefully sliced the tuberous material, noting how a viscous yellowish oil immediately beaded along the cut surface. He began a meticulous extraction, dissolving the root's resins in alcohol, separating the plant's living tissues from the chemical essence of its violence. After days of evaporation and purification, he was left with a concentrated, oily residue. It had the faint, sweet scent of the original parsnip-like root, but its true nature was revealed under the microscope and in animal tests. When administered to laboratory animals, this amber-coloured extract reproduced the exact sequence of events seen in the field. Sudden tremors escalating into violent, uncontrolled convulsions. The chemist had successfully isolated the plant's primary weapon. He named the compound cicutoxin, formally linking the physical substance to the horrific symptoms. This was no longer just a poisonous plant, it was a chemical agent. Cicutoxin was identified as a potent, direct neurotoxin, the specific trigger that could hijack an entire nervous system in minutes. While chemists had finally named the poison, its true human cost remained an abstract theory until a crisp autumn day in 1911 in the wetlands of rural Canada. A forager, his hands caked with damp soil, pulled up a cluster of thick tuberous roots. The earthy, sweet scent reminded him of wild parsnip, and he sliced off a piece with his pocket knife, popping it into his mouth. Within 15 minutes, a deep nausea gripped his stomach, twisting into violent cramps. He stumbled from the creek bank, his vision blurring as the world began to spin. Then the convulsions seized him, his body arching uncontrollably, muscles locking in agonizing spasms on the forest floor, a terrifying demonstration of cicutoxin's power now raging through his nervous system. Bystanders found him in the throes of grand mal seizures and rushed him to a doctor. The medical intervention was swift and desperate, battling the neurological storm to keep his lungs working. He survived, but his case provided a grim first-hand account. A single mistaken bite of that yellow-oiled root could bring a strong man to the brink of death in mere moments. The documented case from Canada had shown the danger was real for people too. So by the 1930s, agricultural extension agents took action. They compiled their knowledge into stark, illustrated bulletins mailed to rural post offices. The warnings were blunt. Learn this plant, or risk losing livestock, or worse. The booklets landed on kitchen tables from the Midwest to the Pacific Northwest, their pages filled with grainy but precise photographs. A farmer thumbing through the new guide would see a close-up of the fatal root. The instructions were clear. Dig one up and slice it open lengthwise. Inside, they'd find not solid flesh, but a series of hollow crosswise chambers. If the cut was fresh, a thick yellowish oil would begin to seep from those chambers, the visible signature of the poison within. This was the definitive test, far more reliable than trusting the parsnip-like smell. The final directive in the bulletin was uncompromising: eradication. Farmers were told to wear gloves, dig out every plant, and burn the roots completely. Simply discarding them was a gamble, as the toxic oil could persist. This campaign transformed local knowledge into a standardized defense, arming a generation with the visual evidence needed to purge the violent plant from their pastures for good. The warnings in those agricultural bulletins were stark, but the precise mechanism behind water hemlock's violence remained a medical mystery. By the 1950s, toxicologists moved the investigation from muddy pastures into sterile laboratories. They needed to see exactly what happened inside a living body when cicutoxin entered the bloodstream. So they turned to controlled animal studies, administering precise doses of the extracted poison. In the lab, a rabbit injected with the toxin provided the grim answer. Its muscles first began to twitch erratically, then seized into rigid, arching contortions completely beyond its control. The animal's breathing grew ragged and desperate as the violent, uncoordinated contractions ravaged its body. This was no ordinary poison. It was a direct assault on the very wiring of the central nervous system. The researchers documented how cicutoxin molecules latched onto receptors in the brain and spinal cord, forcing neurons to fire continuously. This neurological overstimulation triggered the catastrophic muscle spasms witnessed for centuries in fields and farmyards. Ultimately, the relentless seizures exhausted the respiratory muscles, leading to suffocation. The laboratory had finally captured the violent death that farmers had long described. The laboratory studies of the 1950s had confirmed the mechanism, but it was the human cases of the following decades that seared water hemlock's danger into public consciousness. In the early 1970s, a family foraging along an Oregon creek bank made a fatal misidentification. They pulled up what they thought were wild parsnips, their roots smelling sweetly of the earth, and took them home for dinner. Within minutes of tasting the cooked root, the first family member collapsed. Their body began to convulse violently, muscles seizing in a grand maelstrom that medical journals would later describe in stark clinical detail. Ambulances raced through the rural night as the poison cicutoxin flooded their nervous systems, triggering electrical chaos in the brain with terrifying speed. This well-publicized Oregon case and others like it triggered a new wave of urgent public warnings. Newspapers and television reports carried the story, transforming abstract toxicology into a visceral, cautionary tale. The message was brutally clear. A single bite of a root that looked and smelled like food could, in 15 minutes, unleash a neurological violence that medicine could scarcely contain. By the 1990s, the violent history of water hemlock had moved from the pasture into the laboratory. Forensic botanists now possessed tools that could trace a death back to a single plant. Their work transformed the root from a rural hazard into definitive evidence, using its unique physical structure as a botanical fingerprint in criminal investigations. In one pivotal case, a man was found dead under mysterious circumstances. Investigators sent his stomach contents to a specialized lab. Under the microscope, technicians sifted through the digested material searching for clues. Their instruments isolated minute fibrous fragments that didn't belong to any common food. The fragments revealed a hollow chambered structure under high magnification, the unmistakable architecture of a water hemlock root. Chemical analysis then detected traces of cicutoxin. This combination of morphological and toxicological evidence provided the conclusive link, proving the man had ingested the plant and pinpointing it as the sole cause of his fatal seizure. The forensic botanist's identification in the 1990s was not an isolated case. Across rural America, water hemlock continued to claim victims, its danger undiminished by time. A farmer in Montana, clearing a creek bank one spring morning, sliced through a cluster of tuberous roots with his shovel. The cut surface wept that distinctive yellow oil, and the air filled with the sweet, earthy scent of wild parsnip. He knew the smell was a lethal trick. Every agricultural extension guide on his shelf, every foraging manual printed in the last 50 years, placed water hemlock at the very top of their danger lists. The warnings were always the same: identify the chambered, honeycombed rootstock and the purple-streaked stems, then destroy the plant completely. He doused the area with herbicide, his movements careful, knowing a single misplaced bite could be fatal. This vigilance is now a quiet ritual in countless pastures and wetlands. The plant's reputation, built on over 2 centuries of documented seizures and deaths, has made it a permanent spectre. Foragers double-check every white-flowered umbel, and parents warn their children away from suspicious creekside plants, ensuring the legend of America's most violently toxic native plant endures, not just in books, but in lived caution.